Hi guys, it's design time again. You probably remember the announcement I made a couple of months ago, or the introduction I made a couple of months ago of my planned universal high voltage power supply, tube power supply for tube projects. Phase one would be a DC-DC design with many modules that incorporates many modules, a B plus module that goes up to 500 volt and a half an amp, or even more, or 800 volts and a half an amp. We will see. That's for the B plus. Then a screen module that should go up to 400 volts, 100 milliamps, a negative bias, variable and fixed module, and a couple of heater modules that go each up to 15 amps. Anyway, this was not forgotten because you know me, I'm getting distracted very easily. And in between, a lot of other projects came that gained my attention. But now it's time to come back, at least for one of the first modules. This will be the isolated screen voltage module. I'm planning to make that as more or less a 70 watt output in total, and it will be isolated. And even this module, this power supply module, will consist of more of my design modules. First of all, here you see the very, very rough block diagram and how it should look. You have the power stage, you have the PWM stage, and you have the control loop stage here. The PWM stage, I showed it, this design many months ago here. This is one of the modules. You can adjust the frequency, dead time, etc. It's made for a push-pull converter, more or less, yeah. And it has its own driver. It's a TL494. Perhaps I will use a UCC something from Texas Instrument, but for the beginning I will use this one. And it incorporates the MOSFET driver too. So this is this part here, as you can see, this. Then we have the isolated part for the control loop, but it will not be only one control loop, it would be a dual control or double control loop for current and for voltage. And this should be this here. So, and this should be like that, look like that. I'm using this module, it's not finished yet. I'm going to, in a few weeks, we'll finish probably in a week, and will be the size of this one, even smaller. I will make it with PCBA, and it will consist of a low noise power supply. It will be supplied from 12 volts. And here, this part here, will be powered with a DC-DC converter, an isolated DC-DC converter. It goes from 12 volt to 12 volts. So this 12 volts will come from a isolated DC-DC converter, filtered and regulated down to 5 volts, filtered again. And then this would be the connectivity, the outside world connectivity. You have V-Sense, I-Sense, and the OptoCoupler connectivity. On board of this module will be a voltage reference, switchable, with a solder pad in case needed. Otherwise, we will use the 5 volt as a reference. And then you have the error amplifiers, the two error amplifiers for the voltage and for the current. And both of them, the reference voltage will be adjustable. That means you can adjust current and voltage. And I'm going to use an OptoCoupler that will be outside of this module. And this will be a standard OptoCoupler that, as it is shown here. So this is what I wanted to show you. When this is finished, we will take a test drive with it. But now let me show you. This is of course a dual layer, of course a double-sided PCB, what I'm making, and it will double-sided populated. So let me show you the way or the steps I made or was needed to make a double-sided PCB order at PCB way, because there are quite some things that you have to be careful, and you need to put the correct information so you get your design correctly assembled. So let me show you what I mean. So as I said earlier, I'm using Eagle to design my PCBs. It's an old version I have, but I don't need more. I tried KiCad. Honestly, I didn't like it. I tried the test version of Altium. I liked it, but it is so much work to migrate all my hundreds of libraries that I made, so I left it. So for the moment, I can do anything with this version I have here, and the only feasible upgrade, possible upgrade for me to think would be Altium, but this is out of my reach financially. So this is why I'm staying here. Anybody can use what he wants. This, what I show you today, the export of the files, or how to make the files. The export is of course different based on the software you are using, on the CAD software you're using. I will show you how to do it based on Eagle. So first of all, let's go. Okay, here we are. SMPS, Opto-based controllers. I had it already open. Okay, now we have it a little bit nicer to see, the whole schematic. I'm a friend of doing things in modules, so you can, if you don't need that anymore, or you need something more, you just change the module and you have the functionality you want. And secondly, it takes a lot of less space on the PCB because it goes vertically. This is, I can make the PCB smaller. Yeah. Anyway, first of all, we have to export the BOM. And for that, and as I said before, I'm making all my PCBs at PCB way. What I'm receiving from them is immaculate, perfect. Yeah. And I will make the PCBA with PCB way too, as I did for my previous design, the universal front panel design that I make with a microcontroller. So enough blah blah, let's continue. We go to ULP. I'm already here, PCB way, and let's say Eagle BOM. It is very crude what you will get. This is how it looks. I'm doing it with values, because then he puts all the values, all the components that have the same value in one line with a comma, and you just export it. And if you export it, you will see, we will see, one moment. Yeah, I was in the wrong directory, of course. Yeah, Opto-based, that, assembly. So, and you will get this kind of file. Not all this file, but only this part here. I had to do some manual work. First of all, to remove anything that I don't need it, everything that I don't need it, and to do it like that, to have a sorting like that. I'm doing first the resistors, then the inductors, if there are any, capacitors, and then all the other active components or switches and any other stuff. Anyway, this is the base I'm using to feed the Excel file that the PCBA accepts. I will use the quantity, the value itself, the parts, and the package. So, and this is how it looks. This is how PCBWay needs the BOM to be uploaded. You have an item number, that's a sequential number from 1 to n, depending on the unique components, each unique component. The designator, that's the label you have it on the board. The quantity of each unique component. The manufacturer part, and the description, just in case that there is a possibility that you not find it and you can use substitute it with something similar. And the footprint. Everything that is yellow, it is necessary for them to work. Then we need the centroid file. The centroid file is nothing else than a set of coordinates and positions to instruct the pick and place machine where to place the components. So for that we go to the PCB view. We start another ULP, and this one is called Eagle SMT something. Yeah, it is not very nice what you get. And anyway, I cannot read, and I don't need to read what is written here, but this looks like that. We have it. Yeah, it's a CSV file, and it looks, what you receive is something like that. The real coordinates that are necessary are BOM tool. Yeah, here it is. This is what you need. You need a designator. You need the X and Y coordinates. You have to tell them the layer, top or bottom, and the rotation of the component. That's it. These are the two files that are necessary to upload to get your PCB assembled. Let's close it again. By the way, if you like the software I'm using here for that, please consider visiting Soft's PCB software of Rafał Powierski. This is one of the best pieces of software, 3D software of its kind, that I've seen till now. Anyway, let's continue. This is capable of a lot more. Yeah, this is just what the few features that I'm using, nothing more. Anyway, let's close it because it takes quite a power from my PC away. Exit program. I don't need that. So, and let's go to PCBWay. Guys, if you need a PCB or a PCB assembly or CNC machining or 3D printing or mechanical construction, please take a look on PCBWay's site. They can help you with everything. Yeah, but let's go now on what I need. We need PCB instant quote, or yeah, this is how I'm doing it. Yeah, then a quick order PCB. Let's close that. Quick order PCB. So first of all, we have to add a Gerber file, and that's the wrong one. Let's go back and back. Opto paste, this one, Gerbers. Yes, of course. And of course I forget to make the Gerber files. Okay, let's do it together. CAM processor, file, open, job. And I have my Eagle file, process job, neon, close it. So I just generated the Gerbers and zipped them together. And now we have here the zip file. Let's load it. So we see here a very nice view, a 2D view of a two-dimensional view of the front, top and bottom. So what we set here, single pieces. I don't have a panel, I don't need a panel. 2 layers, FR4, the thickness stays. Minimum hole size, let's go down to 0.25. This stays the same price. What does it change? We can stay like that. I don't have smaller holes. Green is the cheapest one. If you go to another color, okay, red is okay, but if you get purple, it gets a lot of more expensive. Let's stay green, I don't need any more. So silk screen is black, UV printing I don't need, a hassle with lead, yeah, that's the cheapest thing, that's leaded solder. I need tenting vias, but this is already set into the Gerbers. What we have here, nothing that I need at the moment. And I need the assembly service. We want turnkey, and we want PCBA to penalize it because of this suggestion here. It's probably easier for them. Then we need both sides, and I need 5 pieces. We don't have really sensitive components. And this here, I want alternatives made in China. Yes. Anything else here? Other parameters? Number 2. No, I'm not interested on that. Depanel the boards to delivery. Do I need that? Does it cost anything? No, then let's depanelize them. Conform my coating, press fit assembly, blah blah blah. I don't need all these things, yeah. Yeah, and I want it in a box with PCBA logo. So we're in Austria, and I want it with FedEx IP IOSS. IOSS is necessary, otherwise you will pay a lot of taxes. So here with IOSS, PCBA charges you the VAT and pays the VAT directly to the Austrian customs. So let's say apply. And save the card. And what is that? That's new patch update, blah, 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 agree. I'm not ordering weapons. So let's continue. Here we add the files now. And we need a part list. Oh, that's complicated now. Again, projects, it is here. SMPS, Opto loop controllers, Opto assembly, and here we need the bomb. Here we are. So, loaded successfully. Looks okay. Then we need the centroid file. And we again will load this one. You can even watch it here and say open. So these are the 2 files that you need to upload for the PCB assembly. And now we have already uploaded everything. The Gerber files, the BOM file, and the CPL file, that's a Centroid file. Now you just have to check them all. So, and again, always it opens a new window that I do not want. Anyway, I'm not really very keen with this OBS. I have to check it. I have to get used of it. Anyway, here we have the PCB and the assembly. And if you go to view details, there have to be an audit here, yeah? So now that we have everything, the engineers will check what you uploaded, and they will give you a quote for the parts here that are used. They will contact you, and if everything is okay, you tell them, yeah, continue, and that's it. So this is more or less what I wanted to show you today. If you like what you see, if you like my videos, please consider subscribing to my channel, give me a thumbs up, and press the notification button so you get informed when I upload a new video. And guys, check PCBWay's website. As I said, it's the one-stop solution for everything that you need: PCB assembly, PCBA, PCBs, CNC, 3D printing, metalworking, and the module shop that they have. And this design, when it's finished, I will upload it as a shared project on the module shop, on the shop, so you can directly order it from them. Good. That's it for now. Thank you. Have a nice evening. Have a nice morning. Have a nice day, wherever in the world you are. Please stay safe, and see you next time. Cheers.